Hello everyone. In this lecture we are going to discuss class 9 topic chapter number 8 trigonometry practice set 8.2. In practice set 8.2 we have first question in the following table. A ratio is given in each column. Find the remaining two ratios in the column and complete the table. So at start we have given cos of theta value is in the first column 35 divided by 37. So we well known cos of theta to be equals to the adjacent side upon hypotenuse. So let's try to construct a one of the right angle triangle, called it as ABC, which is right angled at A, and we are assuming angle B to be equals to theta. So that we have given here cos of theta. So with respect to theta we have adjacent side is AB and the hypotenuse is BC. So cos of theta to be equals to, now we are getting AB divided by BC. So AB divided by BC is equals to, we have 35 divided by 37. That means that should implies now AB is a some scalar multiple of 35. That means we are assuming it as a 35 times x be the any scalar. While value of BC is some scalar multiple of 37. That means we are assuming hypotenuse to be equals to 37 times x. That same scalar multiple we are taking. Now by using the Pythagoras theorem, for any right angle triangle Pythagoras theorem is satisfied. Hypotenuse square equals to side 1 square plus side 2 square. BC square equals to, I am writing AB square plus AC square. So that value of AC square we are getting BC square. Once we shift the AB square from RHS to LHS, BC square minus of AB square. So that AC square equals to BC square means we have now the 37x. So 37x, the whole square we have a 37 square as a 1369, x square as a x square, minus of AB value we have a 35x. So 35x the whole square means 35 square we have 1225 and x square as x square. So after all making the subtraction we are getting AC square to be equals to 144x square. After all taking now square root on both sides, the AC value is 12 times x. So that I am writing on the figure length of AC is equals to 12x. Now it is easy to calculate the value of sine theta. Now with respect to theta we have the opposite side is AC. So that we are getting opposite side AC divided by hypotenuse BC. So that should imply now the value of sine theta to be equals to AC value we have a 12x and the BC value we have a 37x. So here x getting cancelled, so we might remain with the 12 divided by 37. So the value of sine of theta, now we are having 12 by 37. Make up a box to it. Try to evaluate the value of tan of theta. Tan theta to be equals to, as per the relation between trigonometric ratios, we have sin theta upon cos theta. Sin theta value is 12 by 37 while cos theta value is 35 divided by 37. So 37 from both denominators getting cancelled, we might remain with the 12 by 35. So the value of tan of theta we are getting 12 by 35. Now try to note down those two values on the table. We have the sin theta becomes 12 divided by 37 and the value of tan of theta to be 12 divided by 35. Now next to it we have given now the sin theta value 11 divided by 61. So that I am writing the second column. In that second column we have the sin theta value 11 divided by 61. Try to construct again a right angle triangle. Suppose we are having now ABC be the right angle triangle whose angle C to be equals to, now I am assuming theta. So with respect to theta, in a right angle triangle we have opposite side as a AB and the hypotenuse is BC. So now sin theta to be equals to opposite upon hypo, that means we are having now the AB divided by BC value is 11 divided by 61. That should implies now AB is a some scalar multiple of 11. So that means we are assuming that scalar multiple as a x and BC with that same scalar multiple of 61. So the hypotenuse becomes, we have a 61x. By applying the Pythagoras theorem in triangle ABC, we have now the AC square to be equals to again the BC square minus of AB square. That means we are getting 61x the whole square. We are getting 61 square as a 3721, x square as a x square, minus of AB value we have 11x, so 11 square as a 121, x square as a x square. So the value of AC square now we are having 3721 minus 121, we are getting 3600 x square as it is x square. Taking square root on both sides, the AC value we have 60 times x. So that the value of AC we have 60 times x. Now we are going to evaluating the value for cos of theta. So now cos of theta to be equals to, we have adjacent side. So with respect to an angle theta, we have the adjacent side is AC, and divided by we have the hypotenuse is BC. So that should implies now the cos of theta value we are getting, adjacent side is 60x divided by hypotenuse is 61x, x getting cancelled from numerator denominator. Cos theta value we have is 60 divided by 61. Now to evaluate the tangent angle of theta, so again we are using the relation between trigonometric function. Tan theta to be equals to, we are having, I am writing it again, tan theta to be equals to, we are having sin theta upon cos of theta. Sin theta value already given to us 11 divided by 61, and cos theta we obtained 60 divided by 61. So the 61 from numerator denominator getting cancelled, we have tan of theta value is 11 divided by 60. Now try to note that cos theta and the tan theta value on the table. So that cos theta is 60 divided by 61, and the tan theta value we have 11 divided by 60. Now tan theta value we have given in the third column, that is 1. So look at the trigonometric table or the trigonometric ratios of value at a given angle. First I am writing sine, then we have the cos, and then we have the tan. So we well known tan of 45 degree is 1. So what about the sine 45 degree? It is 1 upon root 2, and cos of 45 is 1 upon root 2. So that I am writing the values on the table. Sin theta to be equals to 1 upon root 2, cos theta to be equals to 1 upon root 2, tan theta to be equals to a 1. Now is in the fourth column we have given sine of theta value is half. Again look at the same trigonometric tables of value. We have, I am writing sine, cosine and tangent. Those are the trigonometric ratios. Once we are considering the angle 30 degree alone, sine 30 degree is half, cos 30 degree we are getting root 3 by 2, and tan of 30 degree we have 1 upon root 3. So that I am writing the values. Once the sin theta is half, at that time cos theta is root 3 by 2 and tan theta is 1 upon root 3. Look at the next column, we have given cos theta value is 1 upon root 3. So that again I am writing, we have the cos of theta value is 1 upon root 3. And let's have the right angle triangle again, which is right angled at A, and BC be the hypotenuse. Let us try to consider now angle C equals to theta. So with respect to theta, we have opposite side is the AB, adjacent side is the AC, and the BC be the opposite to 90 degree hypotenuse. So cos of theta we are having adjacent upon hypo, that means we are getting AC divided by BC, that is equals to 1 upon root 3. That means AC is some scalar multiple of 1. We are assuming the scalar multiple is x. So 1 into x, we are having x be the value of adjacent side, and BC be the that same scalar multiple of, we are having root of 3. That means we are getting the value of hypotenuse is, that means the BC is root 3x. Now to evaluate the value of sin theta, we well known sin theta to be equals to opposite upon hypo. That means we are getting AB divided by BC. So sin of theta value we have. Here to evaluate the AB first, we have to use the Pythagoras theorem. AB square equals to hypotenuse square minus side 2 square. So that we are getting BC square minus of, we are having AC square. BC square means root 3x the whole square, we are getting 3x square minus of x square as a x square. 3 minus 1 is 2. 2 times x square be the value of AB square. So the value of AB, after all taking square root on both sides, we have root 2 times x. So that I am writing the value of AB, we have a root 2 times x on the figure. So AB value we have now root 2x divided by BC value we have hypotenuse as a root 3x. X getting cancelled, so now we are getting the value of sine of theta, that is equals to root 2 divided by root of 3. Now to evaluate the value of tangent angle of theta by using relation between trigonometric ratios, we can write tan theta to be equals to sin theta divided by cos theta. Sin theta value we have root 2 divided by root 3. Cos theta value we have 1 upon root 3. Root 3 getting cancelled, we are getting root 2 divided by 1 means a root of 2. So that tan of theta value we have just root 2. So let's plot those two figures on a table. We have the value of sin theta is root 2 divided by root 3 and the value of tan theta is root of 2. Look at the next column, we have given now the tan theta value is 21 divided by 20. So that I am writing the value of tan of theta, we are having 21 divided by 20. Let's try to construct again a right angle triangle ABC which is right angled at A, and consider that an angle B to be equals to theta. With respect to theta, we have opposite side is AC, adjacent side is AB and hypotenuse is BC. Now tan theta we are having opposite upon adjacent, means we are getting AC divided by AB, that is equals to 21 divided by 20. That means the value of AC is a sum scalar multiple of 21. We are having 21x, x be the sum scalar multiple, and AB to be a sum scalar multiple of 20. That same scalar multiple, keep in mind x and x over here. So by using the Pythagoras theorem, we are getting BC square to be equals to now AC square plus we are having AB square. So the value of AC is 21x. The whole square we are getting 441x square, and 20x the whole square we are getting 400x square. Add up them, 441 plus 400 we are getting 841 x square be the value of BC square. Required to evaluate the value of BC taking square root on both sides, so that 841 the square root we are having a 29 and the x square the square root we have the x, so the hypotenuse becomes 29x. Now it is easy to evaluate the value of sine of theta at start and then cos of theta. So sine theta to be equals to, we are having opposite side upon the hypotenuse. So the value of AC we have given here as per the figure, that is 21x, and value of BC we have a 29x. X getting cancelled, so the value of sine of theta now we are having 21 divided by 29. Let's try to make up a box to it. Now evaluate the value of tan theta. We are having the sin theta divided by cos theta. Value of sin theta we are getting 21 by 29. Value of, next to it we have to evaluate actually the cos theta value. Okay. So the cos of theta to be equals to, we have the adjacent side upon hypotenuse. That means the AB divided by BC. AB value we are having 20x and the BC value we have 29x. X getting cancelled, so that should implies the value of cos of theta is 20 divided by 29. So that let's put those two figures on our table. We have the value of sin theta is 21 divided by 29 and the value of cos of theta is 20 divided by 29. Look at the next column of the given table. Again we have tan of theta is 8 by 15. So that tan theta value now we have given 8 divided by 15. That means opposite side with respect to an angle theta is a sum scalar multiple of 8, that is 8x, and the value of adjacent side is some scalar multiple of 15. So that we are getting here adjacent side is 15 times x. So by using the Pythagoras theorem, now we are having the value of BC square is of the form AC square means 8x the whole square is 64x square and 15x the whole square is 225x square. Let us try to add up them. BC square equals to 64 plus 225. We are getting 289 x square as it is x square. Taking square root on both sides, we have now BC value becomes a 17x. So that hypotenuse BC we have 17x. Now to evaluate the value of sine theta, we are having the opposite side becomes 8x and the hypotenuse is 17x. X getting cancelled. So the value of sine of theta now we are having 8 divided by 17. To evaluate the value of cos theta, we have adjacent side upon the hypotenuse, that is 15x divided by 17x, x getting cancelled, the cos theta value is 15 divided by 17. So that the value of sin theta we have here 8 by 17 and cos theta value we are getting 15 divided by 17. Look at the next column, we have given sin theta is 3 by 5. So that I am writing, we have given here sin of theta to be equals to, we have now 3 divided by 5. Try to construct the same triangle, right angle triangle we are having, which is right angled at point A. Angle B equals to theta. With respect to theta, we have opposite side is AC, adjacent side is AB, and the hypotenuse is BC. So now the value of sine of theta, we are getting the opposite side upon the hypotenuse, means we have AC divided by BC, that is equals to, we have given 3 by 5. That means AC is some scalar multiple of 3. Scalar multiple we are taking 3x. So the value of AC is 3x. And the value of BC, that same scalar multiple of 5. That means we are having a 5x. So that by using the Pythagoras theorem, we are getting AB square to be equals to BC square minus of AC square. Hypotenuse square minus of side 2 square. BC square we have now as a 25x square, and while AC square is 3x the whole square as a 9x square. 25 minus 9, 16x square as it is. So that the value of AB square now we are getting 16x square. So the taking square root on both sides, we have the value of AB is 4x. So that I am writing the adjacent side, we have AB, that is 4x. Now to evaluate the value of cos theta, we have the formula adjacent side upon hypotenuse. So that adjacent side is AB divided by hypotenuse is we have BC. So that we are getting 4x divided by 5x. X getting cancelled, the value of cos of theta we have just a 4 by 5. Now to evaluate the tan of theta, sin theta divided by we have the cos theta. Sin theta value already given 3 by 5 and cos theta value we obtained as a 4 by 5. 5 from both denominator getting cancelled. So that should imply now the value of tangent angle of theta we have 3 by 4. Let's put those figure on the table. We have the value of cos of theta is 4 divided by 5 and the value of tan of theta we have a 3 by 4. Look at the last column, we have given tan theta value is 1 upon 2 root 2. So that we are having here value for tan of theta is 1 upon 2 times root of 2. So let's try to consider again the right angle triangle as a ABC, in which angle B equals to we have a theta. So with respect to theta, AC be the opposite side, AB be the adjacent side, and the hypotenuse is BC. So that we are having tan of theta value is opposite upon adjacent, means the AC divided by AB. That is equals to, now we are getting 1 upon 2 root 2. So AC be the some scalar multiple of 1, that means scalar multiple we are taking x, 1 into x is x. While the opposite side means the value of AB is some scalar multiple of 2 root 2. So that we are having 2 root 2x. Let's applying the Pythagoras theorem is in the right angle triangle ABC. We are getting AC square 2 root 2 the whole square. We have a 4 2s are 8 and x square as a we are having x square. So that we are getting 8x square plus x square, that will becomes 9x square. 9x square is a square root, we have a 3x. So the value of BC we are getting 3x. So the sine of theta is equals to, we have opposite side upon hypotenuse, opposite side is AC. So AC value 2 root 2x and hypotenuse we have the BC, that is 3x. X getting cancelled, so the value of sine of theta we are getting here 2 times root of 2 divided by 3. Now to evaluate the value of cosine angle of theta, we have adjacent side divided by hypotenuse be the value of cos of theta. So here AB be the adjacent side whose value we have a x, BC be the hypotenuse whose value we have a 3x. X getting cancelled, the cos theta value we are getting 1 upon 3. So that sin theta to be equals to we have 2 root 2 divided by we have a 3, and the value of cos of theta we are having 1 by 3. Hence we have the first question is in the practice set 8.2. Look at the second sub question from practice set 8.2. Find the values of within it first sub question 5 times sine of 30 degree plus 3 times tan of 45 degree. So look at the trigonometric table. Trigonometric ratios are value, that means the sine of 30 degree we have a 1 by 2 and the tan of 45 degree you may write it somewhere else, that is equals to a 1. So that we have to evaluate the value now. 5 times the sine of 30 degree plus 3 times tan of 45 degree. So 5 remains as it is into sine 30 degree is 1 by 2 and plus 3 remains as it is into tan of 45 degree is 1. 5 into half is 5 by 2 plus 3 ones are we have a 3. Do the cross multiplication so that we are getting the value of 5 times sine of 30 degree plus 3 times tan of 45 degree, that is equals to we are having 3 2s are 6 plus 5 is 11 divided by we have a 2 be the value of now 5 times sine of 30 degree plus 3 times tan of 45 degree. Look at the second sub question from question second. Find the values of 4 by 5 times tan square of 60 degree plus 3 times sine square of 60 degree. So that look at the trigonometric table, we have the values of tan of 60 degree and sine of 60 degree are of the form. I am writing tan of 60 degree value we have root of 3 and value of sine of 60 degree we have root 3 by 2. So that here we have to evaluate the value for 4 by 5 times tan of 60 degree square means the whole square plus 3 times sine square of 60 degree means the sine of 60 degree the whole square. So now let's try to replace by their value. 4 by 5 times we are having tan 60 degree is root 3 the whole square as it is plus 3 times sine of 60 degree we have root 3 by 2 the whole square as it is. So 4 by 5 times root 3 the whole square becomes 3 plus 3 times root 3 square we have a 3 and 2 square we are getting a 4. So that 4 3s are we have a 12 divided by 5 as it is plus 3 3s are we have a 9 divided by 4 as it is. Do the cross multiplication here to add up the rationals. 12 4s are we have 48, 9 5s are we have a 45 divided by 5 4s are we are getting 20. So 4 by 5 times tan of 60 degree the whole square means tan square of 60 degree plus we are having 3 times sine of 60 degree the whole square means sine square of 60 degree, that is equals to 48 plus 45 we have a 93 divided by 20. Hence we have the value of given trigonometric expression. Now look at the next question. Question number 3. 2 times sine of 30 degree plus cos of 0 degree plus 3 times sine of 90 degree. Look at the trigonometric ratios of values. As per the table we are having sine 30 degree is half, cos of 0 degree is 1 and sine of 90 degree is again a 1. So that the value of 2 times sine of 30 degree plus cos of 0 degree plus 3 times sine of 90 degree, that is equals to we are getting 2 into sine 30 is half plus cos of 0 is 1. Next to it we are having sine of 90 degree is 1, so 3 times 1. So 2 ones are 2, 2 ones are 2. So 1 plus 1 plus 3 ones are we have a 3. 3 plus 2 we are getting 5. So the 2 times the sine of 30 degree plus cos of 0 degree plus 3 times the sine of 90 degree value we are getting a 5. Look at the fourth sub question. We have to evaluate the value of tan 60 divided by sine 60 plus cos of 60. So again, As per the table, we have tan 60 degrees root 3, sine of 60 degrees root 3 divided by 2, and we have cos of 60 degrees 1 by 2. So the value of tan of 60 degree divided by sine of 60 degree plus cos of 60 degree, we are getting, it is of the form tan 60 is root of 3 while sine 60 is root 3 divided by 2 plus cos of 60 is half. So look at the denominator, we have rational addition. Once the denominator is same, we can add up the numerator. So that we have now root 3 divided by root 3 plus 1 divided by 2. As per the rule of rational, denominators are denominator shifted over numerator. So that tan 60 divided by we have sine 60 plus cos of 60, that is equals to 2 times root 3 divided by root 3 plus 1. So already we have the method of rationalization. Try to rationalize now the denominator. That means we have to multiply and divide given rational function by conjugate of denominator. We have the denominator is root 3 plus 1, whose conjugate, just change the middle sign, root 3 minus 1 and root 3 minus 1. So try to multiply and divide to the rational number by root 3 minus 1, root 3 minus 1. So that 2 times root of 3 into we are getting root 3 minus 1 divided by a plus b into a minus b, we have a square minus of b square. That means root 3 square minus of 1 square. So that 2 times root of 3 into we are getting root 3 minus 1 divided by root 3 square is 3, 1 square is 1, so 3 minus 1 is 2. So 2 times root 3 into root 3 minus 1 divided by 2. 2 ones are 2, 2 ones are 2. Try to distribute this root 3 over the bracket so that I am writing the value of tan of 60 degree divided by sine of 60 degree plus cos of 60 degree is equals to, we have a root 3 into root 3 becomes 3. So 3 minus of root of 3 into 1 is root 3. So 3 minus root of 3 be the value of tan 60 divided by sine 60 plus cos of 60. Look at the fifth sub question from question number 2, practice at 8.2. Find the values of cos square of 45 degree plus sine square of 30 degree. So we have to evaluate for cos square of 45 degree plus sine square of 30 degree. So cos square of 45 degree we can write cos of 45 degree the whole square plus sine square of 30 degree we can write it is of the form sine of 30 degree the whole square. Now we well known as per the table, cos of 45 degree we have 1 upon root 2 and sine of 30 degree we have 1 by 2. So that we are getting 1 upon root 2 the whole square plus sine 30 is 1 by 2, so 1 by 2 the whole square. 1 upon root 2 the whole square we have 1 square is 1, root 2 square is 2 plus 1 square is 1, 2 square is 4. So LCM is 4. 2 2s are we are getting 4. So try to multiply divide first rational by 2. 2 1s are 2 plus 1 we have here 3 divided by 4. So that I am writing, we are getting the value for cos of 45 degree plus cos square of 45 degree plus we have sine square of 30 degree, that to be equals to now a 3 divided by 4. Look at the sub question 6 from question number 2, practice at 8.2. Find the values of cos of 60 degree into cos of 30 degree plus sine of 60 degree into sine of 30 degree. So now we have to evaluate the value for cos of 60 degree into cos of 30 degree plus sine of 60 degree into sine of 30 degree. So now we well known the value of cos of 60 degree is 1 by 2. Value of cos of 30 degree is root 3 by 2 plus sine 60 degree we have root 3 by 2 into sine of 30 degree is 1 by 2. So 1 into root 3 is root 3 divided by 2 into 2 we have a 4 plus root 3 into 1 we have root 3 divided by 2 into 2 we have a 4. Once the denominator is same, direct addition of numerator, root 3 plus root 3 we have 2 times root of 3 divided by 4. Now we well known 2 1s are 2, 2 2s are 4. So the value of cos of 60 degree into cos of 30 degree plus sine of 60 degree into sine of 30 degree that is equals to, we are getting root 3 divided by A2. Look at the question number 3 from practice at 8.2. If sine theta to be equals to 4 by 5, then find cos of theta. Now we well known the trigonometric identity, which is of the form sine square of theta plus cos square of theta, that to be equals to, we have a 1. So here we have given sine theta equals to 4 by 5. So sine square of theta means sine of theta the whole square. Sine theta value we have 4 by 5. So sine square of theta value we are getting 4 by 5 the whole square. Plus cos square of theta as it is, that is equals to 1. Now 4 square is 16, 5 square is 25, plus we are having cos square of theta, and that is equals to 1. Now once we shift 16 by 25 from LHS to RHS, we are getting the value of cos square of theta to be equals to 1 minus 16 divided by 25. Let's by making cross multiplication, we have 25 minus 16 divided by 25. Now 25 minus 16 is 9. 9 divided by, we have a 25 be the value of cos square of theta. Taking square root on both sides, we have now the cos theta value to be equals to square root of 9, we have a 3. 25 square root, we have a 5. So the value of cos of theta, we are getting 3 divided by 5. Look at the question number 4 from practice set 8.2. If cos of theta to be equals to 15 divided by 17, then find the sine of theta. So again we able to know that the trigonometric identity cos square of theta plus sine square of theta, that is equals to 1. We may write it as a sine square theta plus cos square theta equals to 1, because addition is always commutative. We have given cos theta equals to 15 by 17. So cos square of theta to be equals to 15 divided by 17 the whole square, plus sine square of theta as it is, that is equals to 1. Now 15 square we have 225 divided by 17 square we have 289, plus sine square of theta, that is equals to a 1. So once to evaluate the value of sine square of theta, we shift to 225 divided by 289 from LHS to RHS, plus will becomes now minus, so that we are getting 1 minus 225 divided by 289. By using cross multiplication, we have 289 minus 225 divided by 289. So 289 minus 225, we are getting 64 divided by 289 be the value of sine square of theta. After all, taking square root on both sides, we have now the value of sine of theta to be equals to square root of 64 is 8, square root of 289 is 17. So the value of sine of theta we have 8 divided by 17. So here we have our practice at 8.2. Thank you.